And now let's talk about the pump installations. Normally, we want to move fluids between point 1 to point 2 between two reservoirs, and the fluid is being moved by a pump here. In this line, we have a suction pipe and a discharge pipe. So as the fluids enter the suction pipe, we have head loss at the inlet and we have head loss due to frictions at the inlet. The same terms also apply for the discharge point or the outlet point. At the outlet, we have head loss to the outlet and we have head loss due to frictions at the outlet. So these both frictions are due to the fluid's interactions with the pipeline that causing losses within the flow. Moreover, the distance between the two water level of the reservoir, we can call it as the static head. And to analyze the head of a pump system, we can recall our knowledge on the Bernoulli equations that the head is equal to pressure divided by density multiplied with gravity plus the kinetic energy, V to the power of 2 divided by 2 times gravity plus Z1 or elevations at any points. So it can be between the inlet or the outlet. So these Bernoulli equations, we can use it when analyzing the pump, and it applies for the inlet and the outlet section. So we can write it down for the inlet as pressure 1 for point 1 divided by density, gravity plus velocity at the inlet to the power of 2 times gravity plus elevations at the inlet or Z1. And at the outlet, it becomes P2, pressure at the discharge of the pump, density multiplied with gravity plus velocity at point 2 to the power of 2 times gravity, and Z2 at the discharge point. Combining these two equations, we might have what being called as the manometric head. That is the functions of P2 minus P1 divided by density and gravity plus V2 to the power of 2 minus V1 to the power of 2 divided by 2G plus Z2 minus Z1. Now let's call this is equation 3, and it is also common to write these equations as the total head, that is the functions of static head plus sum of all losses, or we can expand it as static head plus head in plus head due to frictions at the inlet plus head at the outlet plus head due to frictions at the outlet. In some cases, it is also a pump, when a pump being used where the elevations are relatively small, so that the difference between Z2 and Z1 can be neglected, and the velocity between point 2 and point 1 are remain similar, we can simply write the head equations as functions between pressure between point 2 and point 1 divided by density and gravity. This is the case when elevations and velocity don't change very much.